Determining the rate from experimental data. In this problem, it says consider the following reaction and experimental data. We have reaction where we have a reactant A plus a reactant B yields a product AB. So we have a synthesis reaction and it says what is the rate constant for the reaction. So we have to find K. So we know that the rate is usually R times K times the concentration of A times the order, and then B times the order B. So what we have to find out is A and B. We know some concentrations because we have the data, and we also know the rate. So this R, we also know this R. So to find out the rate and find out these coefficients, what we have to do is divide trials where one of the concentrations is constant and see what happens to the rate when concentration of A changes. And then we can see that trial 1 and 2 are those trials. So what we're going to do is we're going to divide the rate. So it's going to be 0.9096 divided by 0.096 equals 0.66 to a power A and 0.55 to a power B. All of this divided by 0.0912 because this is for trial 2, which also equals 0.33 to A, 0.55 to B power. Now when we do this, what we're going to get is 8 on this side. We're going to get on this left side 8 and equals, and we're going to get 2 to the A power. Now, why is it 2 to the A power? This cancels out because these are the same. Even B is going to be the same in both. So this cancels out. And when you divide this, you're actually going to get 2 because we know that A is the same here. But here we can see that the moles of A are actually double. So this becomes 2. And then when you divide 0.96 by 0.12, you get 8. And so when we solve for A, we get that A equals 3. So we know that this A is going to equal 3. Now to do the same thing for B, now we see that A is constant for trials 2 and 3, and we're going to just divide these two. So what we're going to see is that we're going to end up with, also notice that 0.55 and 1.10 are double each other, and A stays the same. So what we can do for this one is notice that this is going to produce equals 2 on this side after I divide 0.024 by 0.012, and that's going to equal 2. And then what we're going to see is when we divide 1.10 to B and then divided by 0.55 to the B power, what we're going to see is that this is going to become 2B equals 2. And then so B must equal 1. So this equals 1. So now we have the rate law. R equals K times the concentration of A to the third power to the concentration of times the concentration of B to the 1 power. So now to figure out K, what we have to do is use one of these, and we'll just use trial 1. And then we'll use it to solve for K. So it's going to be 0.96 equaling K times 0.66 to the third power times 0.55 to the first power. Now, when we do this calculation and we put this to the third power times 0.055 and then divide what we have to move it over to this side, divide 0.96 by what we get over here, we get that K equals 0.61. So that is the rate. So A is wrong, B is wrong, C is wrong. But notice now we have one with different units for D and E. So what we have to figure out is which one has the right units. So what we do is remember that the rate as it tells us, is moles per liter times seconds, which equals K times mole over liters times mole over liters. And we're seeing that because this is what it tells us in the experimental data. And if I manipulate these variables, what I'm going to see is that K has to equal L cubed over S times mole cubed. So that must mean E is the answer to our question because it has the correct constant and also the correct units. So E is the answer to this problem.